Now, the last component I got to put it in is in the GPU. But I think before I go to put the GPU in and the bracket across the top, which is going to take considerable space inside here, I'm going to go ahead and connect all the wires up to the current parts that I have in the build and start doing a little bit of wire management while it's easy to have access to everything. Okay, the wiring is all done. Let me give you a tour of what I have and where all the wires are placed. So if we look at the power lines first over here, we can see them all bundled up nicely. I've got the 24 pin coming up through here. I am taking advantage of that 90-degree adapter that came with the power supply to keep the cables nice and flat. We have the two SATA SSD power wires coming off here and snake into their appropriate spots. On that area, the two CPU 8-pin wires, they're coming in off this way and being snaked around and brought down into here. I will eventually, when I install the GPU, connect in this additional wire harness. The plan is to actually rehold this over the top on the GPU retainer so we can get to the top connector of the card. Let's see, the other wires, if we look at the fans next, we have the 140 millimeter fan. That wire gets tucked nicely into here, connecting the chassis. We got our 80 pin fan. That is nicely connected down into here. Our two front ones are being wired along the floor here over to their specific connectors on that. In terms of the two other wires that are coming up the side here, one's the chassis intrusion switch. The other is a thermal probe. They're a thermal sensor, temperature sensor. I plan on hooking this up to the GPU retainer so I can get the air temperature that's in the chassis, mostly coming from the front end, so I can see what temperature these components are starting from. The only other wires are the SATA data wires. They're coming, one's coming around this way, one's going around that way, and we got our front panel USB wires. So this is the bundle coming up through here, up to the top, and then the front panel ribbon connector with all the switches and that are connected on that side. I wanted to give you a different perspective of the wiring a little lower so you can see how I tried to keep the wires as flat and up against the sidewalls as possible. I'm trying to maximize the amount of airflow that can go from front to the back without having a lot of wires or other things interfering with that along the way.
Hardware. We have like a rubber grommet.
So with that's all set, I think next up is to power this on and see how well this works. Before I did do any sort of powering on, I did go through and make sure every one of these power connectors are tightly connected
and
to
the
where
nice
they
thing
need
about
to
these
go.
feet,
and I actually did that for all the other connectors.
You can see
as
over
well.
here.
That way
they have these
good connections on everything.
On it.
I have
that way we can have
power
our foot
plugged into
either
it.
in the
We've
out
got it hooked up
position
to our
like
monitor
that,
and our
or
separate
we can
cable.
actually
this time we're not going to need our
move it
extra screwdriver. Make sure this wire is not in the way. We're not going to need our extra screwdriver to turn it on because we actually have a power switch on the front.
Now let me
so
go
that's
ahead
kind
and
of
install the other
So
four.
with that said, let's go ahead and turn on the power switch.
With the feet
See the
all
light
installed,
went on
next we
and the
can
tester saying
install
there's
the
power coming
handles
in.
that go on the top.
And
That
let's
makes
go ahead and hit
carrying
it and
the
cross our fingers.
workstation a little easier.
So the first step is to actually screw the handles onto the support brackets. Now the first thing I notice is the fans are all running. Looks like every fan I have is running. In fact, that's a good sign. The motherboard gave us the green light. So that's working. And the BIOS screen is up. So let's take a look at that and see if all the components are registering in correctly. Okay, we have again our memory. We've got our CPU with a nice temperature. We can see all our fans running. This is our fan on the CPU cooler. It's in the middle. And then we got our chassis fans connected to it. I believe chassis 1 is the exhaust, the 140 millimeter exhaust. Chassis number 3 are the two 80 millimeter fan exhaust. And chassis 4 and 5 are the two front fans that are running, so that looks good. And we can see all our hard drives and our M.2s registering in correctly. So at this point, it looks like we're a success. All the wiring is working, all the fans, everything, so we can move on and install the final component, which is the GPU. Now, despite this being a Linux server, and a headless one at that, I will be installing a graphics card. And you can see the graphics card I'll be installing is the Gigabyte Aorus 4090 Master. And this is actually new. It has never been used, but interesting enough, I did buy this well over a year ago, or maybe almost a year and a half ago. So I didn't have to buy it at today's more ridiculous prices. Instead, I actually got it back in the days when the inventory was plentiful and you can pick up 4090s at the MSRP price in that. Now I'm going to be just installing it as is. I'm going to be air cooling it. I do have a water block that I originally intended to use because I bought this originally for a gaming machine that I never did actually get around building in that. So, but the intention for me to use in the Linux server is to use this for AI or machine learning, kind of playing around with the models. And in those situations, a graphics card is a really good accelerator, and having one with 24 gigabytes is a nice foundation of which to kind of play around it. If I do need more down the road, if the models get really big, I have everything set up in the server to support a second GPU, so I'll have the option either of purchasing an additional 4090, or I can move to maybe 5090s, depending on if those become plentiful and at reasonable prices. Now I have opened the box before just to verify that it wasn't visually broken but I haven't really taken out of its wrapper or anything. So let's go ahead and do that now. So it's just some basic, here's our power connector for it, some brackets for holding it, which we won't need because our case has brackets, and of course the graphics card itself. It's all wrapped up nicely in its case. I'm going to go ahead and break the seal on it and open up the graphics card here. Before we go on to put the graphics card into our computer case, I wanted to point out how the actual graphic card influenced the computer case that I ended up buying. You can see on your screen the different specs of the graphics card itself. And the most important spec that I was focusing my attention on was the actual height of it. And you can see that in red is just under 163 millimeters. Now, on a server case, they usually go by what's called units, or how many units tall it is. And 1 unit is 44.5 millimeters. So, you can see what a 4U case, that would be simply 4 times that number, or 178 millimeters. And maybe that sounds like it's tall enough, but when you take into account the additional height for the connector that you can see on the screen, maybe the motherboard, and in this case a tray inside the server case, it starts adding up a little higher. So that's influenced me first to find a 5U height case as a minimum. So next I was looking at Silverstone because I heard good things about their cases and that. And one of the first things I went to look for when I went to a 5U server case was an RM51. Now this seemed like a kind of case that I was looking for, primarily because it's very similar to the RM52. You can see the layout of the case even is very similar. It even has that graphics card hold down bracket on top. But the main difference is the front of the case. It has two large 180 millimeter fans that can go across. And since I knew I was going to do air cooling, at first I thought this would be the more attractive option of having those large fans. But when I dug into the specs itself, I saw that the height of a graphics card with that bracket holding down was a maximum of 158 millimeters, and that was actually less than the 163 of my 4090 card. So that's what got me next to look at the RM52, and you can see the RM52 with the graphics hold down bracket, it actually goes up to 165 millimeters. So their newer case gave a little more height, and that's what ultimately had me pick that case. First thing we need to do is get off the extra plastic and everything from the GPU, and it looks like there's actually a substantial amount of stuff on here. So I got some on the fan hubs, one across the entire front. And then finally we have the PCIe card slot protector. I see I need to take off two of the PCIe slots covers. Alright, with that all done, we should be able to slide it right into the slot. Push down it. Simple as that. Now that the graphics card's in, I've been considering how to put the holder bracket down on it. Now, Silverstone made the case very flexible in terms of where I can install this bracket. From approximately here to here, several different locations, actually. And there's screw holes on the side, so it's very flexible in terms of where we want to put it. I also want to show the detail of these hold-down fingers in that they go on to this bracket here by sliding into these holes. You can sort of see on the bottom of here, there's like little things that stick out. You find the right kind of hole you want to put it in, and you can slide it in and then use the thumb screw to hold it down. And then each one of these fingers, if I can take it out, can angle down to the right hold down position. You can see one side that's kind of indented, the other side's more or less flat. So I've been considering where I want to place it. Now there's a few things I have to take into account. One, there's an LCD screen on it. Now while it's not entirely necessary that I have this visible, ideally it would be visible. I can't necessarily block the power cable here because I have to have the cable coming out on it and have enough room to do that. And at the same time, I don't want it too far forward because that kind of defeats the purpose of the hold down. So after thinking and considering where I want to place this, I think I've decided to place it right about here. I can have this hold down holding this side of the card this way, and I can have this hold down holding the card down that way, and I'll push the bracket as far as I can in this direction, which leaves the power cord slightly obstructed so it's not completely free up. But I was looking at the spec on the Silverstone cable, and it says that we can start a bend at 35 millimeters away from the end of the plug. So I put some blue tape here that are 35 millimeters away as a guide to tell me where I can start the bend. And when I hold up the end of the cable to approximately where it would be, the blue tape is actually under this hold down bracket. So that tells me that I have a little bit of leeway to lean the wire a little bit out to the side, and then I can use this as a guide and a hold down to hold the power cable up and around over to the power supply. And the nice thing about doing that approach too will keep the wire above if I move this out, will keep the wire above the CPU fan, so that way any air coming in this direction, there's no obstruction in terms of air flowing inside it. So I'm going to go ahead and set that up, and let's see how that works. And I got the whole bracket and everything in. It might be a little hard to see from that perspective, but I've inserted some photos in here so you can see different areas, but the fingers are holding down the graphics card on each side. Our power connector is firmly in place. In fact, I even tried to push on each individual 12-volt wire to make sure it was fully seated downward. I got a nice arc that comes up from, that keeps it straight, and the bend doesn't really start at the 35 millimeters. You saw another photo I'll show you in there where the top of the tape is well below the bracket itself. The wires are nicely attached to across this thing here, so it gives a nice bend. They're bundled in over here. In terms of the high power connector on the power supply side, I have basically it coming straight out to about here, so there isn't any bend close to it, and I verified everything's fully seated, including each individual wire. Alright, I changed our HDMI cable over to the graphics card now. It's a little hard to see under this bracket. Instead of the built-in one on the motherboard. We got everything hooked up. The power is plugged back in. I made sure everything was unplugged while we were doing all the work. So let's give this a try and see what happens in that. So this is the first time I've powered on this card since I purchased it a year and a half ago. We have to have our fingers crossed on this one that everything's going to work. I'm seeing the display, LCD display, come alive. That's nice. The fan, the LED fans are running and doing an interesting little light show on it, so that's good. Now I'm waiting to see if the BIOS screen comes up. Okay, we can see on the screen the PCIe 16 slot 1 has a green dot, and it is connected to our Nvidia 4090 card as mentioned up in the top right. So I think we can feel confident that the card is now functional. Well, I have to say, I have it all put back together again. I think we can do a sigh of relief that the GPU is all up and running, considering it's been about a year and a half since I purchased it, and the year warranty is up and that. The case seems to be is all put back together. I got it up on its feet. I have it over here running for about 15-20 minutes or so. If I turn on the screen over here, you can see the temperatures of the case. I'd say the ambient temperature of the room is about chilly down here. It's about 16.5 degrees Celsius. The CPU temperature is 32 degrees Celsius. This is with the case closed and all the fans running in default mode. The T sensor temperature, that's 21 or 69 degrees Fahrenheit. Remember, that's the temperature sensor that is in the middle of the case. So I haven't really changed anything in the BIOS and that. I do want to change one thing, and let's go ahead and enable our XMP settings here. And now the BIOS is back up and running. See up here on the memory settings, 6400 megahertz, which is what the spec of the DRAMs that I purchased in that. Alright, I think everything is working pretty good right now. I think the next steps for me would be to temporarily install Ubuntu and try to do some stress tests and performance testing on the box. And see how the fans, maybe I'll kind of tweak around with the fan settings and see what kind of temperatures I can get when it's under full load. The first set of results I want to show is just an overall system one, and that's the Geekbench 6. I ran both the single and the multi-CPU test, and I ran this 3 times. You can see the results. There are the scores down below across the 3. This is with the Phoronix test bench software on Linux that I was using to run all these applications and that.
And you can see my results in yellow compared to perhaps the average results for a 285K Linux build in that. So they're in the ballpark. We can see here what the ambient temperature of the room at the time it was, what's the idle power of the system when it's doing absolutely nothing, and of that 74 watts, how much is used the CPU at idle and how much is used by the GPU. And then over here on the right, we can see all the various waveforms while running those 3 tests of Geekbench 6. To point out some interesting area, if we look at the CPU usage, it was fairly unused until the multi-CPU stuff was running, so that's when it popped up. We can see the peak numbers. The frequency went all the way up to the 5700 that one might expect for the cores to run at. You can see the power up here. The peak was for some of the multi-CPU near 200 watts, and this is the temperature waveform we can see across running all these tests with a peak of 74 Celsius. I should point out the way they have the fans is what I earlier decided to do, which is to have the front fans and the 140 millimeter exhaust be ramped up or profiled by the CPU activity, which is really sort of the default, and have the second set of front 360 fans as well as the 280 millimeter fans. I'm having that actually ramp based on the temperature within the case itself with that temperature probe. Now, the rest of the numbers in here, they're fairly uninteresting for this particular test, but I have it to be complete. Let's next look at a test that's designed for the CPU in particular, and this is building the Linux kernel. Once again, we've run the test 3 times. You can see the score that I got was 44.5 seconds, which is right close to the average 285K. Overall, across all the ones that are placed on the openbenchmarking.org, it placed 77th on it. Again, we can see the usage is near 100%. We expect our frequency is the top at 5700 and more or less consistent. Here's our power, a little more at 220, and that was again consistent across the 3 tests. And then the hotspot is 84C. So starting to get a little hotter. We can see the CPU fans. The system started cold, kind of started ramping up and holding the fans at the higher speeds up here. Same thing with this is the tower fans, I should say, on the cooler, and these are the front and back fans exhaust, more or less mapping the same. The next test is a CPU intensive one. This is meant to more like sort of like prime numbers, where we're really stressing out the CPU as much as we can. So CPU usage was pegged at 100%. The CPU frequency is 5300, so we can start to see now some ramped out, and that's because the power is at 305 watts, and more concerning is the peak temperature. The peak temperature was more or less pegged at over 100 Celsius now. So this is starting to tell me the air cooling tower has its limits, that when you really do applications that stress the CPU as much as we can, the air cooling of that tower just can't pull the heat off fast enough in that. So that's something might have to look at. And in fact, I ran the C-Ray, this particular C-Ray test. The score, by the way, was really good compared to the average 285K, so it doesn't suggest there's a particular problem with my system. This might be more across different 285Ks. But I did run the second test C-Ray at 4K instead of 1080p, and here we can see a little more obvious that the CPU frequency is being ramped down. Up here the power as well, likely due to the temperatures, trying to hold it more consistent here and that. And the fans, they're trying to do their best in terms of trying to keep it cool, but it's just not keeping up. So again, I'm going to have to kind of look at this and see if a water cool is more appropriate for this area, maybe an all-in-one cooler, and that, especially if I'm going to do these kind of applications. That if I don't do these applications that stress the CPU, then the air cooling is going to be fine. Now, some of the next tests I did, here's one had more GPU based, so we're using Furmark. So you can see some of the parameters here and the score we got compared to the average 4090. So a little bit under the average in terms of frames per second. Over here we can see our GPU frequency, which is really good. That's sort of held itself across the top. The GPU usage was near 100. The GPU power was peaking out and basically holding at 450. And the temperature, while still sort of climbing towards the end, would suggest I could have run it before. It looks like it was starting to level out somewhere around 63 degrees Celsius. And then you can see the GPU fans and how their behavior was going. It's sort of ramping up on this area. And then the case fans itself. These GPU fans is what's built into the card, and this is the case fans. And it more or less was kind of staying at 33%, which would suggest the internal case temperature wasn't really heating up all that much to cause the fans to go higher than that. Stream is a benchmark test for our RAM. So in this particular case, it ran 5 times. The score was pretty good. It was hard to find a comparable score for the kind of RAM that I had, which was 96 gigabytes, but I did find one that was 16 gigabytes rated at the same speed, and we can see our score was a little better than that. Probably over here on this side, you can see some of the CPU usage in that, but maybe more interesting would be the DDR hotspot temperatures. We can see this was the hottest we had of different benchmark tests we were running here, and you can see it's sort of leveling out. In terms of the fans, it looks like the case fans here are running about 50%. So finally here is I ran some test benchmarks across the different storage systems I have between the NVMe, the 2 different types, and the SSD SATA. I used the KDiskMark, and then you can see basically the parameters I have set to it, and that this scores is not what I got. This is what we would expect to find. So for PCIe 5 NVMe, we expect to find about 14,000 megabytes per second, and the 4 7,000, the SATA 550. Where if we look over here on the scores, SATA's in the ballpark, the PCIe 4 is in the ballpark, but the PCIe 5 is not getting up to 14,000. In fact, we're only going up to 9,000. And I did some investigation upon that, and it turns out the design of the Intel chip itself actually has some latencies inside it across die, so it's never going to achieve the 14,000 that the drives can actually go to. In fact, from what I've read, it's about 12,500 is the most it can go to. So if I take that on faith, that 12,500 is what a 285K can do, that would still suggest there's potentially some problems going on with the system, either the motherboard or the drive itself. And I might have to look into that further to see if this is an issue with the hardware or perhaps a software setup issue. In terms of temperature, you can see the behavior of it. The PCIe 5 peaked out, maybe expectedly peaked out at the most at near 54 degrees Celsius, and you can see the activity here while it was running, and you can see the temperatures on the 4 and the SATA.
Many of you probably were observant enough to notice that the build was actually done back in February, and here we are in July. So there was a bit of a gap in there, and I have to say the long time has been mostly some things of life getting in the way in terms of travel and others. I think the other aspect of it was the software for doing the benchmark and the testing in that. The Linux system is not quite as great as in terms of the Windows, in terms of having all the hardware sensors at your fingertips and you know exactly what they are. Linux does have a lot of different sensors, but it doesn't make it very easy to translate that back to a particular fan or a particular temperature probe. Some of the benchmarking software that I was using, the Phoronix thing, it didn't. The sensors or package it has inside there made some arbitrary decisions in terms of where it picked the CPU frequency, or it didn't even have access to things like power on that. And fortunately, you can't keep a good software developer down, so I spent my time customizing the software so I can write my own routines and my own scripts to pull out the pieces of data I want and then wrap that up back as an input into Phoronix so we can get the graphs in that I was showing in that. So I spent a considerable amount of time customizing so I can get you the data as I'd wanted to get it for you. So to kind of wrap up the case and the build itself and that, I was very happy with building this case. This case over here had the features, it had the flexibility, and it had the quality in that. So from if you're looking for like a no-nonsense type server case where you're not necessarily into the RGB bling, but you're looking for something that will really serve you well in terms of server hardware now and in the future and that, I would recommend this. I was happy with what I was able to accomplish with this case and what I'll be able to do in the future. Yes, it's one of those cry ones at the beginning because it's not cheap, but afterwards you're very happy with it, and I can see years to come of enjoying this case. I do have a couple things to follow up on this build, so it wasn't all perfect in that. I think the two things that I pointed out in the testing are the most notable ones in terms of CPU cooling. I have already purchased an all-in-one liquid cooler that I'll most likely be putting in this case and testing out, so that might be a subject of a future video. And I also might investigate a bit more on the PCIe 5 NVMe drive speed and that, see if we can bring that up. And then of course, the box itself, as I originally said, I wanted to be able to do virtual machines and maybe play around with AI, so I may have some future videos where I'm actually using the server and trying out the various different software in that. All right, very good. We made it to the end of all three of our videos in that. For those of you, my friends, who've watched all three, especially if you watched all the minutes in that, I truly want to thank you. This was a labor of love. Well, building computers is something I enjoy doing for myself, and that I wanted to share out in the YouTube community the level of detail that I would like to see when watching build videos and that. So I hope you enjoyed my perspective and the details that I brought with you in that. And if you didn't find it informative, then I hope that it cured any sort of insomnia that you might have had. I'll leave you there. So take care, everybody, and I hope to catch you next time.